Dear students, today we are going to talk about Bohr's model, means the new idea which Niels Bohr brought to remove the anomaly in the atomic model given by Rutherford. And the postulates what he made were, the first postulate was that the electrons revolving around nucleus is provided necessary centripetal force by the Coulombian force of attraction between electrons which are negatively charged and the protons in the nucleus which are positively charged. So this was already known to the world, but the second assumption, the postulate what he made was a big landmark and brought a breakthrough in this world of science. He assumed that the angular momentum possessed by the electrons revolving around the orbit is always equal to nh cut, or nh divided by 2 pi, where n is the number of orbit number, h is the Planck's constant, and angular momentum is moment of momentum, that is mass of electron multiplied by speed of electron multiplied by the radius of the orbit, electronic orbit. So this was the breakthrough. And finally he also took that whatever is the change in energy of electron while it moves from one orbit to another appears in the form of electromagnetic wave which the electrons radiates in case it is losing energy, or absorbs the incident radiation when it is exciting itself, gaining energy and moving to an orbit of higher energy. So we have marked these as equation 1, 2 and 3. Now expression for mechanical energy of the orbital electrons. For that, you see, using equation 1 we can have r, that is radius of the orbit, given by, you arrange one r is cancelled with this, so r is equal to kZe square by mv square. You carry mv square on the right hand side, it goes to denominator. Now from equation 2, mvr is equal to nh by 2 pi, therefore we can have the speed of electron revolving is given by nh divided by 2 pi mr. So we call these as equation 1a and 2a, and using 2a on putting for v square in equation 1a, if you put the value of v square in equation 1a, what do you get is the radius of orbit in terms of other than the speed of the electrons revolving around the orbit, around the nucleus. So we have eliminated v by putting the value of v in terms of r. So we got r radius is equal to n square h square upon within bracket kZe square 4 pi square m, where m is the mass of the electron, E is the electronic charge, Z is the atomic number, and K is the Coulomb's constant, H is the Planck's constant. Now on equating the two values of R obtained from equation 1 and 2, from equation 1 and 2 you can have the value of R. Here you see we have already written R is equal to kZe square by mv square. So on equating you get kZe square by mv square. This is the value of R obtained from equation 1, and from equation 2 we have R equal to nh by 2 pi mv, nh by 2 pi mv. So when you equate these two equations, we get the value, the expression for speed of electron revolving around the nucleus, and that becomes equal to, you see, kjd square is already there, and m on the both sides cancel, one v is also cancelled, so only one v survives, so that taken on right hand side, and you carry the rest on the left hand side, you get k ze square is already there, m is cancelled, so you have a factor 2 pi carried to the numerator on the other side, so k ze square into 2 pi, k ze square into 2 pi, that divided by nh, because one v surviving was carried on right hand side and m on the both side cancel each other. So this is the expression for orbital speed of the electron revolving around nucleus. Well, I believe that it is highly mathematical, but you can understand if you take care and take the pain to understand it. So the kinetic energy of electron can be calculated using the formula half mv square is equal to kinetic energy, and for v we can put the value obtained from equation 5 here. So you get kinetic energy equal to half m into, for v we can write k ze square 2 pi, k ze square 2 pi divided by nh whole to the power 2, and that on solving we get this expression. So I leave this solving this process of solving for you to do it as a homework. Now this is the expression for kinetic energy, and we can also find the expression for potential energy possessed by the electron. You know, potential energy is potential into the charge. So here you have potential due to Ze, charge is K into Ze divided by R, where R is the distance between the charge, the electron and the nucleus. So you get Kze by R into E. That becomes Kze square by R. And for R we can have this value over there. R is equal to n square h square, n square h square divided by Kze square, divided by Kze square 4 pi square m, 4 pi square m. So this will be the value of potential energy of the electron, which is revolving around the nucleus having atomic number Z. So on solving you get, you see, if you solve it you get equal to kze square 2 pi divided by nh whole to the power 2. Let us see how this happens. Kze square is already there, and that in the denominator of this fraction should be reciprocated, so it should go in the numerator, and kze square is there, kze square is there, so we get a square factor for kze square. Now you can write also 4 pi square as square of 2 pi, so kze square into 2 pi, and that whole square. Now n square h square is already there, so we can write it as nh whole square. So therefore we got the expression for potential energy of the electron equal to minus kze square 2 pi by nh whole square. And when you add these two you get the total mechanical energy. Here you have a factor half m, and here have a factor 1 m. So when we add these two, we get half minus half m kze square 2 pi by nh whole square. And when you put the value, I leave this solution for you again. And when you put the value of these terms, means atomic number, charge on electron to the power 4, mass of the electron, value of permittivity, the value of Planck's constant, then you get for the whole except the value of n, you get minus 13.6 electron volt divided by n square. So now the third assumption what he made is whatever is the change in energy appears in the form of radiation. So if the electron is going from higher energy state to lower energy state, it should lose energy, and that energy will be equal to the difference in energy state of the electron in the two orbits, the final orbit and the initial orbit, and therefore that should be equal to energy of final orbit minus energy of initial orbit. And since it is equal to minus 13.6 divided by n square, so we take minus 13.6 in the outside the bracket, and within bracket we write 1 by nf square minus 1 by ni square, where nf is the final orbit number and ni is the initial orbit number. Now the same expression can also be written as, you see, energy radiated is h nu is nothing but equal to hc by nu, because we have c is equal to nu lambda, therefore for nu you can write c by lambda, and therefore we have hc by lambda equal to this factor. So if you carry h and c on the right hand side and leave only 1 by lambda on the left hand side, this ratio is known as wave number, means number of waves per unit length, and that wavelength, reciprocal of the wavelength, will be given by r into 1 by nf square minus ni square, where r is known as Rydberg's constant, and its value you can yourself find out. When you put the value over here, you get this value for Rydberg constant. I believe that you have understood how we are going to calculate the wavelength of the spectra which is being emitted by a particular atom. Here we must remember that we are doing all these exercise for the hydrogen atom, and for that Z must be taken as 1. That's all for today, and thank you and have a nice day.